Hello, good morning. Welcome back to Gini Academy. Today, let us start the fourth chapter, Quadratic Equations. See, in this session, let us understand about this, okay? Just a brief introduction. Quadratic equations and the word quadratic. This word is already familiar to you in the chapter polynomial, right? Polynomial chapter you already come across linear, quadratic, cubic. Is it correct? These words are similar in the chapter polynomial itself only. How the words based on degree of variable. The degree of the highest degree of the variable, is it not? The highest degree of the variable is 1, then it is calling as a linear. If the degree of the variable, highest degree of the variable is 2, then that is quadratic polynomial. If the highest degree of the variable is 3, then that is calling as cubic polynomial. So here quadratic equations means we need to go for only the highest degree of the equation is 2. Equation means you already understood LHS is equal to RHS. For example, linear polynomial, quadratic polynomial, is it not? Cubic polynomial, cubic polynomial, okay? If it is equal to something, then equal to some number or some equation only, some again the expression, not equation, okay? If it is equal to one more expression or constant, then it is calling as an equation. That means something on LHS side is equal to something on RHS side. Clear? So the quadratic equation meaning itself is the highest degree of the variable is 2 and it is equation means LHS is equal to RHS. Let us understand the general formula. Ax square plus bx plus c is equal to 0. Okay. The highest power of the variable is 2. And here a naught is equal to 0. It is the condition. If a is equal to 0, then it won't come under quadratic equation only. Is it not? Only x plus something, that is calling as a linear equation. So that is why the condition is a naught is equal to 0. B can be 0. For example, x square plus 4 is equal to 0. This is also quadratic equation. Only the condition for quadratic equation is the highest power of the variable is 2. Clear? And this is about its general formula and its meaning, quadratic equation. And now let us understand these how to verify whether it is belong to quadratic equations or not. Okay, let us understand whether it is a quadratic equation or not. And see, for identifying it is a quadratic equation or not, we need to simplify this. Okay, and here x into x plus 1, take the x inside, x into x square, x into 1 x plus 8 is equal to, see, x plus 2 into x minus 2. It resembles to which identity? A plus b into a minus b. So what is the answer? A square minus b square. You have to recall this identity, a plus b into a minus b. So that is a square minus b square. See, this is resemble to this, no? So what it become? A square is nothing but x square minus b square is 2 square. Clear? So it become x square minus 2 square. Now x square plus x plus 8 is equal to x square minus 2 2s are 4 and x square plus x plus 8. Take the x square. If something is there on RHS side, if you drag to LHS, then that sign changes. Positive become negative, negative become positive. See, now what and all can cancel? Minus plus getting cancelled and x term is only 1. 8 plus 4 is 12. So after simplifying this, what we got? By this equation we got x plus 12 is equal to 0. Is it quadratic equation? Yes or no? Absolutely, it is not a quadratic equation, because the highest power of the variable, nothing is there means 1 is there. So it is linear. If a power is 1 is, that means linear equation. Is it not? In the last chapter we learned no linear equations in two variables. So that is linear equation. So it is not a quadratic equation. So like this we need to find out. And one more thing, they will ask a question in sentence form, and we need to analyze the sentence and form a quadratic equation. They will give a question, okay? So that we need to analyze and form a quadratic equation. Clear? And that I will tell in the exercise session only. And what next comes means the factorization, finding a solution of a quadratic equation by factorization method. Let us see that. Let us understand finding a solution of a quadratic equation by factorization method. Here factorization we are using the splitting middle term only, okay? Splitting middle term we are using, okay? Let us recall the factorization by finding the solution of this quadratic equation. See here how to do factorization. The term with the variable has to be multiplied with the constant. So 2 into 3, 2 3s are 6. And now we need to find out the multiple of this, wherein the middle term should come by adding or subtracting. 6 is there and we want 5. So how to get? This only, right? 3 2s are 3 plus 2 is 5, okay? So, but here the negative sign is there, be careful. 2x square, how both become negative? Minus 3 minus 2 is nothing but minus 5. So, minus in the place of minus 5x, we need to take it multiple. Minus 3x minus 2x plus 3 is equal to 0. But here, look at here, 2 is there, 3 is there, 2 and 3 is there. Can I change? Like 2x square, take firstly, let me write 2, or else you can take like that only, no problem, okay? What are the common thing here? Only x, remaining is 2x. In the 2x square, if x is taken out, left is 2x minus, in 3x, 3, minus, if you take, you can't possible to take 2 also, only 1 you take out, the left out is 2x minus into plus minus 3 is equal to 0. So the thing is 2x minus 3, one term, and x minus 1. See here, we need to equate these to 0, then only we would have get the roots. 2x minus 3 is equal to 0. 2x is equal to 3 and x is equal to 3 by 2. This is one root or one solution. X minus 1 is equal to 0. If x minus 1 transpose here, it will become positive 1. So these are the root, and we can say it having two real roots. So x is equal to 3 by 2 and x is equal to 1. So this is the way to find out a solution of a quadratic equation by factorization method. Clear? And let us understand nature of the roots. Here I said solution are roots. So based on the nature of this root, we can justify what kind of roots or solution they are. Okay? Let us understand nature of the roots. Nature of the roots is depend on b square minus 4ac, and this is named as discriminant. Discriminant or capital D. Okay. So this is b square minus 4ac. It is the part of quadratic equation formula. Quadratic formula is there. So in that b square minus 4ac is one part that is named as discriminant. Based on this only, nature of the roots are justified. So what we can say means, if D is the first case, if D is greater than 0, what we can justify? If D is equal to 0, then what? If D is less than 0, three cases are there. Firstly, we'll see if D is greater than 0, then we'll get two different real root. Two different or distinct, both are same, right? Real root. If D is equal to 0, then two equal real roots. Two equal real roots. If D is less than 0, then no real roots. Is it easy? Based on the discriminant, we can say what kind of roots they are. If the discriminant is greater than 0, in the last previous problem I said no, the roots are x is equal to 1 and 3 by 2. They are greater than 1, equal to 1 and greater than 1, is it not? So then that is, they are the two different real roots, is it not? One is 1 and one is 3 by 2. And if the discriminant is equal to 0, then we will get two equal real roots. Real roots are equal. If D less than 0, then no real roots at all. Okay. Let us understand this with the example. This is 4AC. This is represented as a D. Let us take one quadratic equation. Okay. And we can find its roots. Here no need to go for factorization method or quadratic formula. If they ask you to find the nature of the roots, you can go for the discriminant b square minus 4ac. Is it not? And here compare these with the general equation. What is A? 2 and B is minus 4 and C is 3. Is it not? So D is equal to B square means minus 4 whole square minus 4 into A C. Minus into minus plus 4 2s are not, be careful, that is 4 into 4. 4 into 4 is 16. 4 2s are 8, 8 3s are 24. And here what we got? 16 minus 24 is minus 8. So D is minus 8. If the D is less than, minus 8 is nothing but less than 0. Therefore, the discriminant is less than 0. So, it means no real roots for this. For this equation, no real roots at all. I hope you understand after the example, right? So, this is very important. Keep in your mind b square minus 4ac. So, that is nothing but discriminant. If the three cases are there, if it is equal to 0, greater than to 0, less than to 0, then what? Clear? Find the solution of quadratic equation by quadratic formula. Quadratic formula is x is equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. You have to practice this quadratic formula. And observe here, this is b square minus 4ac is nothing but discriminant. Is it not? B square minus 4ac. So, in the place of that, we can take square root of d whole divided by 2a. Clear? And let us find the solution for these two equations by using the quadratic formula. Let me take first one. X square minus 4x plus 3 is equal to 0. See here, quadratic formula, in the quadratic formula discriminant is there. Firstly, we will find the discriminant, okay. So, D is equal to b square minus 4ac. So, what is b dot? We have to compare this with the general formula ax square plus bx plus c is equal to 0. What is a? 1 and b is minus 7 and c is 6. Now, the d is b square is minus 7 whole square, 4 into a is 1 and c is 6. Again, if wherever the square is there, be careful. Minus into minus plus 7 into 7, 49. 4 ones are 4, 4 6 are how much? It is 24, right? 6 ones are 6 2 6 6 4 are, yes. Do subtraction. 9 minus 4 is 5 and 4 minus 2 is 2 and we got D 25. Clear? Once we find the discriminant means you can substitute back to the formula. See here, minus B is what? Minus 7 plus or minus square root of 25 whole divided by 2 into A is 1. Minus into minus plus square root of 25. You are well familiar with the square root, no? Square root of 25 is 5. 2 ones are 2. 7 into plus or minus 5 divided by 2. That means 7 plus 5 divided by 2 or 7 minus 5 divided by 2. It leads 2 roots, is it not? One is plus and one is minus. If we do plus, 7 plus 5 is 12. 12 by 2 is nothing but 6. 7 minus 5 is 2. 2 divided by 2 is 1. So therefore the roots are x is equal to 6 and x is equal to 1. And these are d is greater than 1. So 2 distinct real root. Clear? Understood? I hope one example is enough because in the exercise we will see more some related to this one. Okay. This is about introduction. See, under the introduction we discussed what is the meaning of quadratic equation. Okay. And why, how to judge the given equation is a quadratic, and finding a solution of the quadratic equation by factorization method, that to purely splitting middle term method, and this one the root of nature of the roots by using the discriminant, and finally find the solution of the quadratic equation by quadratic formula. Quadratic formula is very important, you have to go through like this. Clear? And this is about introduction. In my next video I will start the exercise. Thank you.